This is the Statistics Review number 4 video guide. The standard error is the standard deviation of a sample. Let's go back to number 1. The margin of error is a multiple of the standard error. Now, why is it a multiple? Because whatever that multiplier is, it gives you a specific confidence. Number 3, the 10% rule. The 10% rule says as long as we don't sample more than 10% of a population, then we can use the standard deviation formula and not have to worry about the independence condition. So we can ignore as long as we don't sample more than 10% of the population. Finally, large counts. Having at least 10 successes and 10 failures. Now this is when obviously we're talking about proportions. Guarantees the sampling distribution is approximately normal. In practical terms, what that means is that now we can use the z-chart or the z-table. Increasing the number of trials decreases the confidence interval length. Why should that be true? Well, think about it this way. As you increase the number of trials, what's happening is your aim is getting better. It's like concentric circles. You're honing in on the target even better. 6. A confidence interval is an attempt to capture a parameter. The key is the parameter. We're looking for a number that comes from the population, not from the sample. We already got a value from the sample. That's usually called p hat or x bar. But the key here is the parameter from the population. Number 7, to be 95% confident, the length of the interval must be approximately 4 standard errors long. The reason I say that is when we look at the formula for 95% specifically, it has a 2. And the reason it has a 2 is that's because of the 68, 95, 99.7 rule. If we go 2 standard deviations out from the mean, we are 95% confident. Well, if you go 2 standard deviations out, or 2 standard errors out, because a standard error is a standard deviation of the survey or the sample, then 2 standard deviations out will be 1, 2 on this side, and -1, -2 on this side. Well, think about what that total distance is. That total distance is 4 standard errors. Number 8. When a statistic contains too much bias, a confidence interval around it becomes meaningless. You may be tricked into thinking that you can fix bias with some statistical manipulation or technique, but that is false. The principle is you can't fix bias. What you've got to do is you've got to try to eliminate it before the survey even happens, by either the way you select people to be in your survey or by the way you ask the question. But you cannot, after the fact, remove bias. And the reason is very simple. You don't know what the bias was. Your own biases may have entered into it. Number 9. A Gallup poll found that only 28% of American adults expect to inherit money or valuable possessions from a relative. The poll's margin of error was 3% at 95% confidence. Interpret what this means in context. Okay, before I actually do the interpretation, let's look at what the confidence interval would be. If it's plus or minus 3%, that applies to the 28% from the sample. So 28 minus 3, that would be 0.25 or 25%, and 0.3 added to 28% is 0.31. There's a spread there of 0.06. Double the margin of error should be the length of the interval. So now our interpretation. We are 95% confident that the interval 0.25 to 0.31 captures, now remember this refers back to a parameter, the true percent of American adults expecting to inherit money or valuables. Number 10. According to a Gallup poll, 64% of teens have a TV in their room with a margin of error of plus or minus 3%. What is the interval of plausible values at 95% confidence? Plausible values. That's what a confidence interval is. It is a group or an interval of plausible values. So really, this question is just asking us to find the interval. Well, the interval goes from 64% minus 3%, so from 61% up to 64% plus 3%, or 0.67. There's the interval, and that's the answer. Number 11. The Gallup Youth Survey asked a random sample of 439 U.S. teens aged 13 to 17 whether they thought young people should wait to have sex until marriage. The 95% confidence interval for the proportion who said yes was 0.514 to 0.606. What is the point estimate for the survey? A point estimate is coming from the sample. It's the number you got when you sampled. However, that's not in the stem of the question. We have to figure it out from the interval. Remember, the interval is 2 standard errors long. So right in the middle is where you're going to find the point estimate. All you've got to do is average these two numbers, and you're going to find the middle of the interval, which is where the point estimate is. 0.56. That's the point estimate. Number 12. In 1952, Dr. Virginia Apgar suggested 5 criteria for measuring a baby's health at birth: skin color, heart rate, muscle tone, breathing, and response when stimulated. She developed a 0, 1, 2 scale to rate a newborn on each of the 5 criteria. A baby's Apgar score is the sum of the ratings on each of the 5 scales, which gives a whole number value from 0 to 10. Apgar scores are still used today to evaluate the health of newborns. What Apgar scores are typical? To find out, researchers recorded the Apgar scores of over 2 million newborn babies in a single year. Imagine selecting one of these newborns at random, and that's our chance process. Define the random variable x is the Apgar score of a randomly selected baby 1 minute after birth. The table below gives the probability distribution for x. A healthy baby is considered to have an Apgar score of 7 or more. What is the probability that a baby in this distribution is healthy? Well, the answer comes from adding up all the numbers from 7 to 10 healthy babies. 0.099 plus 0.319 plus 0.437 plus 0.053. And you're going to find that the vast majority of babies are born healthy. It's 0.908. Of course, that doesn't mean that the other babies are going to die. It just means that they might need some immediate medical attention. 13. Let the random variable x represent the height of adult females in the United States. Research has shown that the mean height is approximately 65 inches with a standard deviation of 3.5 inches. What is the probability that x is greater than 72? And that would be a 6 foot tall female. So what we have to do is find the z-score and then look that number up in the z-chart and then make sure we have the correct probability. So the z-score, the data value here would be 72. The mean is 65. And the standard deviation is 3.5, which gives us a z-score of 2. So I'm going to look up a z-score of 2. A z-score of 2 is 0.9772. But then I have to ask myself, is that the answer to the question? Is that the probability that the randomly selected person would be greater than 72 inches? False. That is the probability that a person would be less than 72 inches. So I need to subtract from 1. And there's the answer. About a little over 2% of adult females are at least 6 feet tall. Number 14. A baseball team plays 20 games. They won 14 of the games, giving them a 70% winning percentage. Let's assume that p hat is 0.7. What is the standard error of this sample of games? Also, another question, if they continue playing this well, what is the 95% confidence interval for 40 games? So the first 20 games are a sample. Okay, they have a 70% winning percentage. That's the p hat being 0.07. What is the standard error? The formula is, for proportions, it's the square root of p hat 1 minus p hat over n. And that's 0.7 times 0.3 divided by 20, because the sample is 20 games. We'll go to 3 decimal places on this. 102. So about 10.2 is the standard error. If they continue playing this well, what is the 95% confidence interval for 40 games? Well, p hat plus or minus 2 times the standard error is going to give us the confidence interval. And that is 0.7 plus or minus 2 of these 0.102 scores, which is 0.204. Okay, so if I go 7 plus 0.204, 0.7 plus 0.204, that gives me 0.904. And if I go 0.7 minus 0.204, that gives me 0.460. So between 0.460 and 0.904 is my 95% confidence interval.